Today we're going to start chapter 14. The section we're going to be looking at is 14.1, linear measure. And the first thing I want to talk about is what linear measure actually means. We've sort of been using it even now before we got to here. But linear measure refers to measuring in a straight line as with a ruler, just like you did in your activity. Okay? Keeping in mind, of course, distance is never negative, so we're only using positive values. And no matter whether you measured, say for instance, from your height from the floor up or your height from your head down, you got the same thing, right? That's what that's saying on the third thing here. And there are two primary systems of measurement that we'll talk about. English, so that's the yards and the feet, things like that. And then metric, the one that you guys did your activity in a minute ago. Standard common use units for measurement for our English system are the foot, the yard, the mile. So these are equivalents that some of them you just have memorized. I suspect that you have memorized that there are 12 inches in a foot. I hope so. 3 feet in a mile, 3 feet in a yard, and those sorts of things. But you might not know that there's 5280 feet in a mile. That might be one that you weren't aware of, right? Same thing for the 1760 yards in a mile. So I know Elena said earlier, these are some of these things I see myself writing on a note card. That may be the case. But if you wrote down 3 feet equals 1 yard on the note card, I would be a little concerned. Okay? So use that space well. Be careful as you make those decisions. All right, so the first thing we're going to do is we're going to do some conversions in the standard English system, just so that you can have some fun and say you did it. Okay? So I mentioned this as being called dimensional analysis. So what we're going to do is we're going to write our, let me use black, 72 feet, and we're going to multiply it by a ratio. The ratio needs to have feet on the bottom because the feet have to cancel out. And the goal is to get feet into yards, so the yards will be on top. Now occasionally, let's say that we were going from inches into yards. You might not go straight there. You might have a two-step process, okay? So you don't necessarily have to write down the first value unit, in this case feet, and second value unit yards on top. You can do an intermediate step in between. And then you write in the ratio correctly. All right, I said correctly, didn't I? Yeah, correctly in there in the right places. So when we're looking at yards and feet, there's going to be a 1 and there's going to be a 3. Where's the 1 going to go? This one's on top because it's 1 yard that equals 3 feet. And then, in doing this, of course, we did this so that the feet will cancel, and we're left with yards. And we end up with a 72 divided by 3. And what is 72 divided by 3? And feel free to grab a calculator if you don't already have it out. What is it? 24. 24 what? Yards. Units are they're always important. I shouldn't even say it now. But they're extremely important in what we're doing here because that's the whole point, right? That's the whole point. All right, next one wants us to go from yards into miles. All right, so we can go straight from yards into miles. You do have a conversion factor of that on the previous page. I will tell you that I don't know the yards to mile conversion. I do know in my mind the feet to mile conversion because I've done it before. So you have to keep in mind what it is you do and don't know. So if I were doing it with the information I actually knew, I'll show you what it will look like. And then I'll show it how you can do it directly, okay? So 8923, whoops, not 30, 23 yards. And the measurement that I know is that 1 yard, which I'll put on bottom, right, yards on bottom, is equal to 3 feet. That's the conversion I know. And the other thing that I know is I know the conversion between feet and miles. So feet here and miles here. And the conversion is that 1 mile is 5280 feet. That's the one that I memorized somewhere along the way. And the other way you could do that is you could start with the 8923 yards. Apparently I really want 30-something yards. 23 yards. And they gave you a conversion that went straight from yards into miles, which would be okay to do as well. What's that conversion? 1 mile was 1760 yards, right? So this is what it would look like if you went using that comparison. Either way, you end up with the same answer. Now, notice, of course, that, again, our goal was to get units to cancel. They canceled here on the left. Of course, they canceled here on the other one on the right. We're left with miles. If we do this on the first one, we end up taking 8923 times 3, hit enter, and then divide by 5280. If you do on the second one, you're doing 8923, just divide by 1760. Either way, you're going to get an ugly decimal value, aren't you? Did anybody do it? Yeah? It's an ugly decimal value. We're going to go with 2 decimal places unless we're indicated to do otherwise. So what would this be to 2 decimal places? So technically we're doing an approximation here. I guess I'll use my approximation symbols. What do we get?
5.07.
5.07 what?
No, miles.
Miles. And we do need the MI. Don't just put M. M means meters. Okay, so we'll do MI, or you can write out the word miles. It's fine too. All right, the next one is a really good example of one where you're going to do a 2-step process on this one, right? That middle one, number 2, is kind of an optional. Depends on the perspective you looked at it from, what you remembered. This last one, I'm sorry, I don't know any miles to inches, and I'm not going to learn them. So let's actually convert between what we do know. I know that my miles to feet comparison. And if you don't want to do miles to feet, you can do miles into yards and then yards into feet. So you can do extra on this one if you go through the yards. But I know that I have miles on bottom and I have feet on top. What is the ratio of feet to miles?
5,280 feet to 1 mile.
Fabulous. 5,280 to 1. Now I've taken care of my miles. I'm no longer in miles, I'm in feet. But I don't really want to be in feet, I want to be in inches. So feet will go on bottom in order to cancel out, and inches will go on top. And what's the corresponding ratios? What are the values that go next to feet and inches here? 12 inches, 1 foot. And again, the feet cancel, so I'm left with my inches. And how are we going to find the number of inches that I'm left with? Lots of numbers across the top, right? So you're going to take 37 times 5280 times 12. It's a big number. Somebody tell me what you get. Just tell me the numbers in order. We can put the commas in afterwards.
2,344,320.
And that's inches, right, Elena? Yeah. And if we go backwards, then I get 2 million. 2,344,320 inches. That's a lot of inches in a mile, isn't there? Yeah, actually, 37 miles. All right, any questions on that? So raise your hand if you appreciate the metric system a little bit more after even just those 3 conversions. Yeah. Even when they're not hard, they take several steps and a whole bunch longer to do than just moving decimal places around, right? They do. The international measurement, especially in science and industry, is the metric system. The cool thing about it, as we've talked about, is it has multiples, uses multiples or fractions of base units that are given by powers of 10. And the prefixes correspond to various multiples and fractions for all types of units. Okay, we've already talked about many of these things. And this was the same chart that you have on a handout that I gave you, right? So you've got the kilo, hecta, deca, and then deci, centi, and milli. Okay, so those are our prefixes. And the metric units that take meters into each one of the others look like this for meters, specifically, as opposed to any measurement, liters or grams. A couple of really good estimates to keep in mind are these. A kilometer is about 9 football fields, including end zones. Okay, have you guys been to a football game somewhere in your life? So you have an image of what a football field looks like. So if you ran 9 of those, you'd have run a kilometer. Okay? A meter will be from the tip, and again, these are approximates, from the tip of your finger to your opposite shoulder is about a meter. My favorite measurement for me, what happened when you did the doorknob down? What'd you guys get? 93 centimeters? Almost a meter, right? Because it'd be 100 centimeters per meter. That's my favorite measurement for meter, is to think about the doorknob down, because we see doorknobs everywhere. You know, I mean, this one isn't bad, but I have to kind of go like this. And I like the doorknob picture better. I think that gives us some perspective too. Occasionally a problem that I have seen used before in a is this reasonable kind of thing is a baby is born. Like Dr. Marsh is about to have a baby, right? Baby is born, and it is, 15 centimeters long. It's awfully tiny, right? Probably not the standard baby born. That would be very preemie. So those kinds of things, like that measurement gives me some perspective. You know, that's toddler up to the top of that doorknob, right? You know, infants aren't that much different in size. All right, a couple smaller ones. Centimeter, the tip of your finger. And since we all have fingers, that's helpful to see, right? You can see that one pretty easily. And then paper clips, which we're all very familiar and comfortable with. The width of the clip itself is 1 millimeter. Cool stuff. So what we're going to do next is you guys are going to use the wonderful tools that you have already been using from the activity that we did to convert these for me. So I'd like for you to fill them in quickly, and then you're going to tell me the answers so that we can fill them in quickly together. So kilometers to meters, millimeters to meters, and then kilometers to centimeters. Bless you. All right, what did we get on the first one?
1,680 meters.
Okay, does everybody agree? Is that what everyone has? Good. What did you get on the second one? What did you get, Matt?
0.973 meters.
Okay, does everybody agree with Matt? Is that what you have? Yes.
I do have a question. Will you require a 0 before the decimal?
I don't care at all. Yeah, if you just put the decimal point in the 973, we're good with that. All right, what did we get? I did sort of the middle of the room. How about on this side, one of you ladies? What did you get for the 0.42 kilometers into centimeters?
42,000.
42,000. Does everybody agree? Fabulous. All right, we're going to shift gears a little bit, talk a little bit more about some shapes and linear measure next. I don't think that we're going to actually finish this today. No excitement?
No.
Oh my goodness, okay. I don't think so. Yeah, but the bum, of course, is that over the weekend we're going to have both the other, this one and the other one. So sorry, so sorry. All right, well, let's take a look and see how far we get anyway. Triangle inequality. The triangle inequality says that if you have any two measures of a triangle, the lengths, sides of the triangle, that their sum has to be more than the third side of the triangle. Okay? You've probably also heard this said a very different way that says something like this. The shortest distance between any 2 points is a straight line, right? The way that I can get from here to here, distance-wise, in the shortest amount of space, is to draw a straight line between them, correct? So what does that mean? Well, it means that if I were to ever try to take two different paths to go get in there instead, I would go further. It's exactly what the triangle inequality says. Any two of the sides have to add up to more than the third. And it's not just equal to the third, it's more than the third, right? So take a look at the first one. Can these numbers be the sides of a triangle? 5, 7, 13.
No.
No. What's wrong with this?
5 is 7 equals 12.
The 5 plus the 7 equals 12, and 12 is actually less than 13. That's a problem, right? So what would happen if I tried to do this? So let's imagine you had a stick of wood, and we'll use meters since we've been talking in meters. You had a stick of wood, it'd be long, 5 meters long. And you had another stick of wood that was 7 meters long, and a third stick of wood that was 13 meters long. What would happen if you tried to make a triangle out of them? It wouldn't connect, right? The image would look something like what I have over here, except that it wouldn't be long enough. The two shorter pieces would not be long enough to actually meet up. No matter how close they got to the longest side, they wouldn't be long enough. Okay? How about the second example, 5, 8, 13? No, because they're equal, exactly. So again, no, because the 5 plus the 8 is equal to 13. Still not okay, right? Which is, in fact, we'll do it this way. It's not greater than or 13. It's supposed to be greater than or equal. No, greater than. I said it right the first time. I just wrote it wrong. It's not greater than 13, which is supposed to be. This first one is less than 13. It's not greater than 13. That's a problem. It's supposed to be greater. What would happen on this one if you tried to do it? You took those 3 pieces of wood and you tried to fit them into a triangle. What would happen? Yeah, they'd be exactly the same length, right? So it basically would be 2 segments on top of each other. So if you imagine having one segment, here's my 13, and then I have another segment, here's my 5, for example, and then you had your third segment, here's my, 8. They'd be right on top of each other because they'd be the exact same length. That is not a triangle, right? Not a triangle. It's not disconnected, but it's not a triangle either. Another linear measure is a measure called perimeter. So perimeter of a simple closed curve is the length of the curve. Now, I realize that what we drew in this picture and what we've been talking about in the majority of this class are not what you guys probably would have described as a curve because they have these straight edges, right? But we use the word curve very loosely in geometry, right? We talked about the word curve once before. It doesn't have to be curvy to be a curve. So this image is a curve, and it is simple and it is closed. Do you guys remember what the words simple and closed mean?
Simple, it doesn't intersect it itself.
Good, so like no figure eights, right? Good. How about closed? What does closed mean? Good, same starting and ending point. So this particular picture, this triangle, it qualifies, right? Simple, closed, curve. The perimeter then is the distance around the outside edges of it. So if you were to add up all these values, you would find the perimeter. So what would you get if you were to find the perimeter of this object? Okay, is everybody good with 40? Was it 40? 30, I think. 30 is what I have written down. I'm sorry. 30 centimeters. Is everybody good with 30? Excellent. A very specific type of perimeter is called circumference. Okay, so there's really not a difference. It's just a more specific name for the same thing, and it's only in reference to what object? Circles. Or portions of a circle occasionally, but usually circles. For a circle, when we talk about the perimeter, we usually refer to it as the circumference. And a diameter is the distance from edge to edge through the center. Okay, so let me see here. Here we go, more or less. Here's my circle. So the distance all the way around is called the circumference. If we go straight across this thing through the center, and it doesn't have to be horizontal, you can go like this. That was not good. Let me try that again. That's closer. Through the center, we have what's called the diameter. Okay, it has to go through the center. If it does not go through the center, it has another name. The diameter is twice the radius. So the radius would go from the center just to the edge of the circle. The diameter goes straight across the circle through the center. And then the ratio of the circumference to the diameter is equal to the irrational number pi. Now, you usually see it written like they did down here where it says circumference equals pi d, right? That, or some variety of that. The other one, circumference equals 2 pi r. But what they're basically saying is that if you take the ratio, if you take the circumference and you compare it to the diameter, that is by definition the number pi. Okay, that's what pi is. Pi is actually the value that you get when you do that. Now, had I been thinking better, we would have had one more activity today. One of the things that I remember very vividly when I did geometry was that we talked about this number pi. And my teacher brought in CDs, which I don't even know, do they make enough CDs anymore that I could find enough for you guys? Probably. But she did use CDs, and she used other circular objects, so my sonic cup would work just fine to do this with. And we actually took tape measures and we measured around the objects. And we measured across, the diameter of the object as well. And we came up with the ratio pi. That's exactly what we did. So as we're working with these, sometimes the pi d is the most convenient, sometimes 2 pi r is more convenient. It doesn't really matter. Obviously, they're not that different of formulas, but we can use either one of them to find different values as it relates to the circumference of a triangle. I didn't mean triangle, I meant circle. Sorry. All right. Maybe we will get finished today. There's only 2 more slides. Oh, man. Let's see what we can do. Arc length. A central angle of a circle is an angle whose vertex is at the center of the arc of the circle and whose sides are the radii of the circle. So if you're dealing with a circle and you take the point in the center and you have 2 of the radii of the circle, this angle right here is called a central angle. Angle in the center. Sides are radii. And then when it talks about, and you know what, I'll mark it here the way that they have. We're going to reference this as the angle theta. It looks like a 0 with a horizontal line through the middle of it. And then this one talks down here of the length of a circular arc. So if we were talking about this particular object that I've already drawn, it's talking about this length right here, which is a portion of the circumference, right? It's a portion of the circumference of the circle L. And the formula that they give you right here is related to the other formulas we've seen. Circumference is 2 pi r. Okay? Well, if you were to take 2 pi r and divide by 360, well, that would ratio it out into the individual degree measures. So where's the 180 coming from? Well, the 180 reduced with the 2 pi, the 2 and 2 pi r, right? So if you had 2 pi r, and you have this angle that you're working with, and you had 360 down here, because pi is equal to 360, then these two could reduce to the pi and the 180. That's where that's coming from. And what this would do is this would allow you to find the arc on a piece of pizza. Right? The arc on the edge of the clock, the arc on whatever it is you're working with. The length would be determined by that central angle. And we do have 4 examples left. Let's do the first one only, and then we'll finish it next time. How's that sound? Okay. The first one says, a circle has a diameter of 4 divided by pi. What is the circumference? So how could we start this problem? It's relating the circumference and the diameter, right? So I would be most inclined to use the formula that related the 2 of those quantities together. It wants us to find the circumference, and they tell us that the diameter is 4 over pi. And you notice what? Yes, and you're left with 4 centimeters. Thank you. 4 centimeters. All right, let's write down the formula for the next one and we'll pick up there next time. If a circle has a circumference of 0.68 meters, what's the radius? So this one compared to the last one, what formula would be most natural to use?
0.68
Yeah. So we've got the circumference equals 2 pi r, and then we can evaluate this. We can put the values in for c in this case when we do this problem next time. Okay, so we'll start with this formula instead of the pi d formula. And we'll pick this up next time.